Welcome back to topic 29, rational exponents. This is part 3. So parts 3 and 4 are going to refer to the foldable. For this foldable, you will need to fold it in half, almost like a book, but instead stop at the vertical dashed line. So that way it reveals on the side the title of rational exponents. The first panel that we're going to deal with is the top panel, which looks like this. So the first few problems, I'm going to fill in the second column, and then we're going to fill in the last two columns. So if we have the square root of b, that's the same thing as b to the 1/2. So we can rewrite this if we have the example square root of 49 as 49 to the 1/2, which is 7. b to the 1/3, or the cube root of b, let's try the cube root of 64. That is the same thing as 64 to the 1/3, which is the same thing as 4. And again, if you need any help with this, feel free to use the chocolate bar method that I mentioned in part 2 to help you simplify these. Let's say we have the 4th root of b, which is b to the 1/4. Let's do the 4th root of 81. So that's 81 to the 1/4, which is the same thing as 3. 5th root of b, let's do the 5th root of 32, which is the same thing as 32 to the 1/5, which is equivalent to 2. 6th root of b, which is 6th root of 64, also known as 64 to the 1/6, which is the same thing as 2. So that is the top first panel. If you open up the top first panel, you will get the inside problems. So these are the inside problems on the left side. So let's practice translating these problems into radical and exponential form. So if we look at the first problem, it is written in exponential form. So we have an exponent of 1/2 right here. So we know that 1/2 is the same thing as square root. So this is the same thing as 14. On the left side, we have 5x to the 1/2. Now notice how this 1/2 is just connected to the x. It does not have parentheses around 5x. So 5x to the 1/2 is not the same thing as 5x to the 1/2. See how I have parentheses? That means that 1/2 would apply to everything here, whereas this part, this x to the 1/2, the 1/2 is only going to the x. So if we want to rewrite this problem, this is the same thing as 5 times the square root of x. Similarly, with 17y to the 1/3, that 1/3 is only attached to the y, so we can rewrite this as 17 times the cube root of y. Next row, x to the 1/3, this is the cube root of x. 19ab to the 1/2, again, this 1/2 is only attached to b. So our 19 and our a are going to be outside of that root. So it's going to be 19a times the square root of b. And then the 4th root of y is the same thing as y to the 1/4. 12, the square root of 12n, because this entire quantity is under the radical here, that means that this entire thing of 12n is all raised to the 1/2. So see how I did those parentheses there. Cube root of b is b to the 1/3, and square root of 37 is 37 to the 1/2. Now these examples we can't simplify any further, so we're all done. Okay, next side, we are simplifying now. So some of these are written in radical form, some of them are written in exponential form. We're going to simplify either way. 49 to the 1/2. Well, that is the same thing as square root of 49. which is 7. 25 to the 1/2. That's the same thing as the square root of 25, or 5. 27 to the 1/3. So that's the same thing as the cube root of 27. So what number times itself again gets you 27? That is 3. After a little while, these numbers will start to kind of reappear, and you will get the hang of seeing some of these problems like reoccur. 64 to the 1/3. So that is the same thing as the cube root of 64, which is 4. 100 to the 1/2. That's the same thing as the square root of 100, which we know is 10. 4th root of 16. That's the same thing as a number times itself again, gets you 16, which is 2. Square root of 144 is 12. Cube root of 125 is a number times itself again, which gets you 125, which is 5. And square root of 64 is 8. Thank you for watching part 3.